My name is John Mitchell. I'm a product manager with Intrepid Control Systems. I'm going to be giving a review of our cloud-based data logging system. This is our data logger that's called the Fire 3. It has 16 dual wire CAN networks and 8 LIN networks. And in this demo, we are generating traffic with a simulator, CAN traffic with a simulator. And we also have 2 of our RadIO2 TC modules that are logging thermocouple data, and both of the simulated traffic and thermocouple data is being logged by the Fire 3. And the Fire 3 is connected to our cloud-based system using the Rad4G, which is an external device that plugs into the Fire 3. And it's connected to our cloud-based server here, which we call a wireless neoVI. And this is the dashboard for wireless neoVI. And this is an application that we can put on a server that we host, or we can deploy it on our customer's server and they can host it. And the vehicles are organized by fleet. So this is a fleet of vehicles. And this particular vehicle is, if you click on one of the vehicles, it'll show you the dashboard for that vehicle, which we're looking at here. And it shows you all the current activity of the device. So if I hit this mic 2 trigger to trigger a buffer capture, it will dump the running buffer on the Fire 3, and it'll also record an audio message that you can annotate the trigger, so you can tell what caused the driver to push the button. And so you can configure the script remotely with wireless neoVI. So if you are looking at some data and you want to add signals, you can create a new script using our Vehicle Spy software and then upload that script to the server and send it to one or more loggers that are on the server. And if you want to analyze data from a device, you just click on the device and click on the data archive, and you can see all the data files that were uploaded for the device. Every row here is a collection of data that's been uploaded. And if you click on this link to the data, it opens the data file in Data Spy, and it shows you all the channels that are in the file. It has the channel name, the comment, and the units, and the number of records for each channel in the file. And if you click on these headers, it'll sort by it. So I just sorted them all by the units. And then here you can select a few channels like trans output speed, trans turbine speed, and engine speed. You can click and drag those onto the plot. And here I'm going to plot them all on the same common axis. So it plots all 3 of those signals. And you can zoom in and out on the y-axis with the scroll wheel, and you can zoom in and out on the time axis with the scroll wheel. And you can add a new YT plot, and you can plot some torque signals. And you can display the grid lines. And this is just a browser page, so you don't have to install any software to use this. You can use it from any platform, Linux or a cell phone or a Mac, because it's just a browser. And as long as you have an account on the server, you can analyze the data. And the great thing about having it on a browser is if you find some event of interest, like this shift bump here, you can copy a link to the event to your clipboard, and you can IM that link to a colleague. And when your colleague clicks on the link, it takes them right to the same data. So this is not a screenshot of the data, it's the actual data. And your colleague can then add some other signals to try and debug the events, and then send you back the link, and you can collaborate with just sending links back and forth. You don't have to move files around, which is really an advantage, a growing advantage now that the data files are getting so large.